Welcome everybody to another one of James's videos. Today we're going to be dealing with the type 3 of setting up of a triangle type question. As you can see, according to type 2, it's the same heading when an equation given. The only difference now is that in type 2, we didn't know what the angle was, but we knew the sides, where it's now reversed now. So now we know the angle, which is 63, and we do not know what the sides are. The sides are in terms of a variable. Okay, so this is how we go about answering this type of setting up of a triangle question. The first thing that we do, remember in type 2, we would obviously simplify the equation so that it's a trig ratio equaling a fraction. So cos of 63, I'm also going to put steps to this one. So step 1 would be taking your cos of 63 equals p and making it a fraction. So how do we make anything a fraction? If it's a whole number or if it's a solid thing, we just put it over 1. Okay, so what's that telling me? Well, cos we know is adjacent over hypotenuse. So already, before I've even drawn my triangle, guys, I know exactly what my adjacent side and my hypotenuse side is. Okay, step 2 is working out the quadrant. Now remember, I'm going according to the same steps as in type 2 for the previous video. So step 2 would be working out the quadrant that we're going to be drawing our triangle in. And it's actually a lot easier than the type 2 setting up of a triangle question. Instead of doing the cast diagram and all that, all we have to look at for the quadrant is the angle, which in this case is 63. So where does that appear? Where does 63 exist? Well, it exists in the first quadrant. Hence, that's where I'm going to be drawing my triangle, because we know what the angle is. The reason why we had to figure out the quadrant in the previous type 2 example is because we didn't know what the angle was. It was unknown, whereas here in this version or in this type, our angle is known. Okay, so then we go straight on to step 3, which is drawing. So let's draw. We know we're going to be drawing in quadrant 1. So let's draw a nice big zoomed in version of quadrant 1. Let's draw our line and then draw our right angled triangle. Remember, and I'll say it again, we drop the vertical line down to the horizontal axis, not to the vertical axis. We don't draw a line here to create our right angled triangle. We draw it over here. Okay, remember that, guys. So let's put in the information that we have. Well, we know that this is 63. We know that my adjacent side is p, my hypotenuse is 1. And then because we know two angles in this triangle, this is 90, this is 63, surely we can work out the third angle in our triangle by going 180 minus 90 minus 63, and that gives me 27. A lot of people forget to do that we can actually solve for the third angle in our triangle. Cool, so we've got a y-axis, we've got an x-axis, and we've got all our information drawn in. Now, the second step, or the fourth step, sorry, is exactly the same as in the previous type of question that we did, and that is Pythagoras' theorem. Okay, so we're going to have to do Pythag in order to work out our opposite, Pythagoras. There we go. In order to work out our third side. That's the side that's unknown at the moment. So, we're going to say hypotenuse squared equals opposite squared plus adjacent side squared. So 1 squared equals p squared plus my adjacent side squared. Let's bring this over. So we're going to have 1 minus p squared equals our adjacent side squared. And then we can square root both sides. Therefore, my adjacent side is equal to the square root of 1 minus p squared. Okay, so we can put that in. A lot of people ask me, James, why can't we apply the square root to that? Guys, we can't apply the square root to that because of this negative. You can't apply the square root to more than one term expression. So in this case, this is a binomial in the square root. You cannot apply the square root to that. Okay, great. So next, we've got step 5, which is answering the questions, right? Because our triangle is now full. So questions, let's have a look. Number 1, we've got sine of 27. Okay, so sine of 27. Sine is opposite over hypotenuse. Sine of 27. 27, do you see how important it was to get that third angle in the triangle? 27 is now what we're dealing with. The opposite side to 27 is P, and the hypotenuse is 1. So my answer would be P over 1, which is equal to P. Okay, the second question is tan of minus 63 degrees. Okay, guys, so we're dealing with a small acute negative angle here, and there's a few rules, and I'm going to kind of go across here just to show you what they are. When we're dealing with small acute negative angles, we're using these rules, and these rules can be found in the James book, which is available for purchase. I'll mention that at the end of the video. So if we get anything, and obviously we're occurring that theta over here is definitely an acute angle, okay? But what we would do, the only one that doesn't change its sign, so this would become minus sine of theta. This would be positive cos theta and minus tan of theta. So the only one that doesn't change its sign is the cos. Because also, you know, if we think about it, if this is our cast diagram, if we know that if we have positive degrees, we're moving in a direction like this. We're moving in an anti-clockwise direction. But if we have negative degrees, we're moving in an anti-clockwise direction. So if I'm moving anti-clockwise by an acute angle, I will be ending up in this quadrant, hence why cos remains positive and sine and tan become negative. Okay, so that's just a visual way of seeing it, but there's also nothing wrong with learning these off by heart and just knowing that when you do have a negative acute angle with these three trig functions, they do turn into the certain things. Cos is the only one that doesn't change its sign. So with that theory, we can then state that that would turn into negative tan 63, and tan of 63 is opposite over adjacent. So opposite 63 is this, adjacent is this. So my final answer would be minus the square root of 1 minus p squared all over p. And that would be my final answer. Okay, so this is another type of example where we are dealing with an equation given, but the only difference is that we now know what our angles are, but we do not know what our sides are. Okay, fantastic, guys. I hope you enjoyed that video. If you are keen to see more, please click the subscribe button. And if you are keen for notes, the James book is available. Please comment and or get in contact with us, and we can make sure that we can get you a copy. Awesome. Have a great one. Cheers.